So my name is Cécile, and Cristina and I actually met at UCL, where we both studied biochemical engineering, and we graduated last September, so it's been almost a year. And it's nice to see that after a year we're still kept in touch and still presenting together, which is nice because we don't live in the same countries at all. And we came across the BioLady network through a project we did at UCL in our second year. So it was one of the scenario weeks organized by Brenda on LCA analysis and world bioenergy production. And during the last day of the project, we had a presentation, and that's where we actually met Iris, who came and looked at our poster presentations and actually selected us to be the winning team of that session because we had this like team dynamic and well, actually really enjoyed working on the project. And I guess you could see that, yeah. So after graduating UCL, I did another degree in renewable energies, which I'm currently finishing. And starting October, I will be working as a renewable energy consultant at E4Tech in London. So yeah, that's me.
And well, for me, well, Cécile said we met in UCL, and I guess that since we both graduated, we've always like found a way to or an excuse to work together again in related topics. And well, since I graduated, I started working at Deloitte as an energy consultant. From many different perspectives, but I miss a lot the let's say the bioeconomy part, so that's why I'm still trying to get involved in different projects and different things that have to do with it, and hopefully redirect myself there again. So yeah.
Okay, so what we're going to present to you today is slightly different than the talks we generally have at those meetups. It is actually, so Borg Energy is actually a work in progress. It is a project I first presented at the Global Go Green Challenge, which is organized yearly by an energy company. And that project was selected as one of the 7 European finalist projects. So it basically means that this project has already gone through a lot of iterations, has already received feedback from experts in the field. But the idea now is to keep working on it, improve it, and hopefully build a prototype someday. That would be like the ultimate goal. You will see that the link to biology is not as obvious as with other projects and other talks we have. But this whole concept, this whole project, the concept of the project is inspired by biological phenomenon. So in a way, it's kind of like biomimicry. Okay, so let's dive into it. So as you know, the energy landscape is changing, and the tools, infrastructures, processes need to be adapted to those changes. So as the number of renewable energies increases with the higher number of PV panels, wind turbines, smart meters, and so on, we need to have the right infrastructure to respond to their intermittent nature, to their fluctuating production at local level. And that's where microgrid can be a very interesting solution, because microgrids essentially are a small energy grid that allow to optimize and manage energy resources at the local scale. So they allow to optimize, moderate the fluctuating energy that comes in. And because they don't have long distances of electricity to manage, they're more responsive to small changes and frequent changes. Generally, microgrids manage energy resources either for households close to the microgrid or for individual buildings, or sometimes for industrial sites. So as you know, the energy transition revolves mainly around 3 pillars, which are producing clean energy, energy affordability, and energy security. With Borg Energy, we want to address the third point, which is energy security. Because one important feature of microgrids is the ability to communicate so that all the devices that are part of the microgrid infrastructure can communicate with each other. Because in a way, that's how you optimize all the modern optimization tools. And by communication, I mean network communication, so wireless connections. So basically that means that's how you transfer data. Communication in very simple terms just means exchange of data between different devices. So exchange of information, which can then be optimized and addressed to the specific scope. But the problem with such systems and problems with systems that rely on data and communication and connections is in case the network fails and in case the connection fails. In that sense, it means that different devices can't transfer data anymore and cannot communicate anymore and can't optimize the energy resources anymore. So that leads to inefficient networks and also energy losses. And that's, in very simple terms, this basically means that with Borg Energy, we are a way to deal with those network failures. We're kind of like an optimization platform in a way to deal with those communication errors. Okay, so let's take a step back and look at the microgrid infrastructure as it is today. Traditionally, microgrid infrastructures, they follow a centralized topology where you have a centralized pre-assigned controller, which is labeled DC on the slides. That controller collects all the information, so all the data transfer is collected at that specific point. And from that point, it communicates with the central database where all the algorithm and optimization calculations and so on occur. And if there's no problem in the network, this works perfectly fine and you have a perfectly optimized system. The problem occurs when there's a failure in the network, as you can see with the little zigzag sign on the slide. So in case of a single point failure, it means that at least one part of the network won't be able to communicate with the controller of the network. You can see the controller as the master or like the boss of the network, the one that takes all the optimization decisions. But if part of the network can't communicate with that controller anymore, there's part of the network that is not optimized. And so that leads to inefficient use of energies and energy losses, and in some cases also economic losses. So what we propose with Borg Energy is to adopt a different topology. So instead of relying on one centralized system where you have one pre-assigned and fixed controller, the idea is to use a decentralized system where different nodes in the system, so different devices which are part of the microgrid infrastructure, can all communicate with each other through wireless connection. And if we adopt this decentralized topology, it means that if one of the nodes in the systems fails, so if the connection between one of the nodes and the main controller is interrupted, the whole system will trigger a self-healing mechanism or a self-healing algorithm, which will reassign a new controller. So in very simple terms, it means in the centralized topology, you have a pre-assigned controller which is fixed, and if the connection to that controller fails, your system is not optimized anymore. And with the Borg Energy decentralized topology, the idea is that if the connection to your controller fails, it's not a problem because you will reassign a new controller and then you can keep optimizing as if nothing had ever occurred. That's, yeah, in very simple terms.
And well, Borg Energy was inspired on a biological principle called quorum sensing. And quorum sensing is a decentralized biological process by which a community of cells with no global awareness can coordinate their functions and make local decisions. So for example, bacteria can produce and release molecules that increase in concentration as a function of cell density. So similarly to the cells in quorum sensing, in our solution, smart meter nodes can sense the state of other smart meters in the cluster without relying on a centralized overview. So we have also identified other shared features between Borg Energy and quorum sensing. First is that our tool is responsive and allows for a quick recovery after a cluster partition. Second is the essential ability to acclimatize to our environment prone to disturbances. And third, efficient decision-making without a pre-assigned central controller. And well, after studying the current ecosystem, we decided to target Borg Energy towards microgrid managers and manufacturers, so both B2B and B2C, as an integrated IoT bundle. So in order to achieve this, key partnerships with distributed energy resources manufacturers will be essential to develop the final product. And well, for microgrid managers, the integration of Borg Energy will mean being able to deal with these demand response inefficiencies and energy waste by producing real-time contingency analysis and solutions. And this will result in reduced operation costs and higher asset health. as well as minimized power interruption costs due to system disruptions. And this could approximately tangibilize as 10 to 15% of cost savings. And at the same time, it could translate into reduced energy prices for end users. And additionally, it will allow for data monetization opportunities, which will have to be implemented through strategic partnerships, as this software will be collecting accurate energy consumption data and patterns from multiple sources. And well, as we previously mentioned, the limitations in the current distribution infrastructure lead to a lower portion of renewable sources incorporated in the grid, and furthermore, low asset utilization and large amounts of energy waste due to inaccurate demand planning and the unidirectional flow of energy. However, decentralizing the control system in microgrids will allow for a higher portion of renewable energy sources to be integrated. Additionally, to minimize energy waste as a result of the real-time accurate resource management. And it will also allow air pollution management through peak demand responses. And additionally, the flexible nature, it will allow to integrate further optimization initiatives in the future, like energy trading or energy storage. And that's it. Thank you so much for listening, and please feel free to make any comments or ask any questions.